Okay, so we built Advanced LIGO. Okay, and let me tell you first, before I tell you what's inside Advanced LIGO, how an interferometric gravitational-wave detector works. First of all, we have a laser, we have a beam splitter, and two mirrors, and the fourth very important component of the interferometer is a detector. So beam splitter does what its name is. It splits the beam to two directions. You know, the N mirrors, it reflect the beam. They come together, the splitter again, and they can interfere with each other destructively. So it's a dark, no signal situation right now, or constructively. And that depends on the distances between these two mirrors. If the distance is changing, for example, due to an incoming gravitational wave, we are going to see some changes on our photodetector. So that's the idea behind detecting gravitational waves using interferometer. Okay? All right. So, of course, there's a bit more to that. But first, let me tell you what 4-kilometer detector means. This is Manhattan, and I tried to draw this interferometer on Manhattan, more or less, at scale. Okay, it's the width of Manhattan. All right, and there is a little bit more complexity than those couple optical components which I was telling you at the previous slide, but some of them are very important. One of them is suspensions. So we have all these mirrors. They are suspended on wires, basically. They are also seismically isolated. Okay? So because we are on Earth, there is a lot of vibration. We want to measure, what was it, 4 times 10 to minus 18 meters displacement, which is already hard to believe we can do that, especially when there's so much noise. But within a given frequency range, we can really seismically isolate these mirrors which we are using in LIGO. So there is actually a sensitive frequency band which goes from around tens of hertz, 30, 50 hertz, all the way up to a couple of thousand hertz. We are pretty sensitive at that level of 10 to minus 21 strain. All right, so suspensions, seismic isolations. And then there are a couple of these additional optical elements which we really need. If we have more photons in the interferometer system, we are going to have less noise. So we can increase the number of photons by doing some optical tricks. One of them is something which we call a recycling mirror. We put a mirror there which is very reflective on this back end, and a lot of the laser light goes back into the interferometer itself, and we can put these input mirrors and actually build up something which we call a cavity in each arm. So we have quite a bit of power in those two arms of the interferometer. So at the end on each mirror there's quite a bit of power. All right, and then we have, of course, the detector itself on that end. So how do we collect the data, and what is the data that we collect? First, we can actually move these mirrors. We have a very complicated control scheme for the detector. We can move one of the mirrors. So what we are doing is keeping this photodetector under dark condition. So like we don't have any signal, dark mode. Okay? And if something is moving and changing, this signal from here is going back to the mirror, and we are moving the mirror, and this control signal is recorded. So that's what we are doing. All right, there is one more very important part of the LIGO detector, which I did not tell you about, but incredibly important, and that's vacuum. Everything is in vacuum. And actually, LIGO is the most expensive nothing on Earth. We imagine a 4-kilometer L-shaped instrument. And if you go to LIGO, even right now, sometimes they let you in, sometimes we are hoping to take data very soon, but sometimes they let you in. There are tours in Louisiana, also in Hanford, Washington, and if you're lucky, you can go and see these huge vacuum chambers. This is a chair here, so from that, you know, a human would be around this height up there. So these are really amazingly big vacuum installations. Actually, the majority of the cost of the original LIGO experiment was this vacuum system. This is the only thing which we really didn't change for Advanced LIGO. So the inside of these beam tubes were stripped out and changed to new instruments, which made the detections. So this is the